think we're here. Clonk. A good reputation is something to prize and cherish. I guess so, yeah. Hope you're doing well. Um. Oh wait, I want to check the YouTube stream. Okay, it is going. Okay, so last night I think I figured out the answer to number 6 here, but I'm not really confident that I actually did. Joseph, congrats on the first. And I was hoping to check my answer somehow. And that means I need to figure out an f of x to try for my initial condition. And like a Gaussian is a pretty natural choice, especially with the heat equation. I just don't want to have to go through the actual... It's worth doing. I don't want to go through the actual process of like doing this inverse Fourier transform, but I feel like I kind of need to. So that's my initial condition. I should... Oh, that's a terrible line. You know what? Fuck it. We don't need it. So... First we need to find the Fourier transform of this thing, which is that formula right there. And I know that Gaussians are still Gaussians. After a Fourier transform, but I think they get scaled somehow. So I can't just say it's going to be e to the minus k squared, unfortunately. E to the minus ikx. E to the minus x squared dx. What I could do, because this integral is kind of a pain, I've just remembered last semester, or quarter, same thing, when we were learning about Fourier transforms, my professor gave us just a straight up formula to use for this annoying type of integral. Because it's like, it's not that bad to figure it out, it's just a lot of algebra. And algebra is kind of the worst. Stooky, hello, hello, meow, meow. Bilinear transformation is going to be before. Oh, I think we have liftoff here. Could I have written better notes? This might not be it. No, this doesn't look like it's it. Does it though? It almost does. Oh, that might be it, but it doesn't look right still. It doesn't look like what I have. Let me just go back another page or... Ooh! Oh, yes! Yes! Okay. Thank God. I am. Hey, Zach. So... I think I solved this problem at the top here last night. But I'm not confident that I actually got the right answer. And so what I was doing right now is I was just kind of choosing an initial condition with a Gaussian, and I was gonna use that to kind of like check my answer. But yeah, I this problem, like, I'm gonna scroll up and show you all the different attempts that I made on this problem over the last week. Let me get to the top. Okay. Attempt number 1. Attempt number 2. Attempt number 3. Number 4. 5. And that's no? Wait, no, that's what I no, this is 6. It was my 6th attempt. Oh my god. But yeah, so I got something involving the gamma function, and I feel like in asymptotic analysis, if you have gamma, you're probably not that far off. But yeah, I was just plugging in an example initial condition here, and I'm going to see if my answer is going to match up. I just don't want to actually do this integral, and so I was looking through my notebook. Oh no, it's got a sign flipped though. Okay, fine, we'll do it the old-fashioned way. We'll complete the square resident sleeper. So what am I doing? X squared plus IKX. Complete the square on that. Hey, BR Gaming. B over 2a. That's the thing that we do plus and minus of. B over 2a squared. Yeah, okay. And there's a negative sign in front. Nope. There we go. And now we do a change of, well, yeah, I think we... Let me just write it out, because the thing I'm a little bit concerned about are the bounds of integration. I think they do change. They don't just stay infinity. I just said they change and I didn't change them. I think it's minus infinity plus ik over 2. Like, I think this is real infinity, or like infinity on the real line, and so the imaginary piece doesn't interact with it. I want to say that's how this works. I guess we could always unsub and not have to worry about it, though. That's probably a better idea. E to the minus k squared over 4. Wait. Crap. I've done this before. This is actually kind of annoying. I don't quite know what to do with this now. Fourier transform of a Gaussian. Surely this is worked out. This is a pretty common thing for people to work out, and we can just find. I hate it when I Google something and the top answers you can easily Google this. It's like, that's what I did. I know they're not talking to me, but. Wait. Integration by parts. Really? Hmm. DCI Banks, hello, hello. Hope you're doing well. Welcome in. Begin with. This is such a weird. A weird idea. This is the same definition of Fourier transform as mine, though. So can I just take their result at face value? Thing is, what is my sigma? Well, okay, they have this constant in front of it. I should be able to make this work. Maybe. This is a lot of effort just to check an answer, but I feel like I need to do this. So if sigma is equal to 1 over root 2, just trying to force the exponent to match, g of x is equal to 1 over root pi e to the minus x squared. Do. And so I think I'm just going to get root pi times this. I kind of... just want to send it. Do. Yeah, this is... I'm really confused about what to do with these imaginary bounds for the integral. I do think they're important. And I can see it... like, I think it's going to work out where I would eventually get this answer. I just don't know the exact steps to do it, because this doesn't integrate nicely, I don't think. Okay, but I'm just gonna take this as my Fourier transform. Some question marks there because I just want to add to the confusion. So my f hat k is going to be root pi e to the minus k squared. I just hope that's right. And so that means my u of xt is 1 over 2 pi hardlocked. Might be the first time that anyone has ever said that. Yay, math time. Good to see you, though. Wait, e to the ikx. Your kids love math? How did you get them to like math? That's like an impossible task. Hey, Jed. It was pretty good. Like, it's a low bar, but it's probably the best pie that I've made. There's a lot that I could have done better still. But, like, overall, not bad. It could have used a little bit longer in the oven, and I messed up the crust a bit, but all things considered, not bad. Both went to community college to compete in a math competition. What? That's awesome. No, they kind of need a long time to cool down, so I was the ultimate tease. And I ended the stream without actually trying it. Oh, yeah, there was definitely a funny moment. A whole month. Holy crap, Jed. Thank you. Oh, and Math Pond with the raid. Thank you so much. Why is my alert delayed again? Gold, hello. I hope you're doing well. Rex, hello. Math Pond, I hope your stream was good. Feel free to raid and run if you'd like. As always. But yeah, if you're sticking around, I'd love to hear how your stream went. Riyadh, Arid, Irad. What delightful music are we listening to? That's a good question. I put it on Spotify Radio for the song Selfless by The Strokes. This particular song is oblivious, but not spelled right. I'm typing it out. Did some probability for the first time. Ooh. Probability is really good to know, but it can be a little annoying. You'll make a profitable transaction next month. That's not a bad fortune, I guess. There's been worse. Average of logs and logs of averages. Fair enough. Some man named Jensen. So yeah, so what's happening here is I'm working on some homework for my asymptotic analysis class. Oh, Jensen's inequality. I have heard of that. I forget what it's about, but I know of it. So yeah, I'm working on kind of a generic solution to the heat equation with Fourier transforms. But since we have a general initial condition, we're just doing an asymptotic expansion for large T. And I think I found the answer, but I was really struggling with this problem, and so I'm taking an example f of x and plugging it in and seeing if my expansion looks reasonable to check it. A rendition of Joseph Fourier doing a Fourier transform. All right. I know that Fourier has his hair looks like a poodle. Let's get a reference image here. Remember 3 Blue 1 Brown, and his Fourier transform video was kind of a savage. Where am I going to draw this? I guess down here is as good as anywhere else. Let me change the page color. We're going to go... Ooh, is that a good white? That's not a bad white. There's Fourier. Expect my drawing to look the exact same. Actually, no, not the same. Better. Okay. Well, we should start by drawing. He's going to be working. We have a white background, and I prefer them, so he's going to be working on a whiteboard. It's not period accurate, but who cares? Check out Fourier's grave while it's in Paris. Really? You did. You should have. If you specified chalkboard, you would have had me. That's actually a great idea, Syntax. Also, you're visiting Paris? That's crazy. Does his Wikipedia page say? Oh, yeah. His name is inscribed on the Eiffel Tower. 72. Wow. Okay, that's 2 cool facts that we just... He used to have a statue, but it was melted down during World War II. Huh. Period. That's my kind of joke right there. The largest cemetery in France. Yeah, they take visitors. It's... Wait, necropolis is a real thing? I thought those were just in, like RPG games. Or RPGs, I guess. Okay. But maybe his grave, like, I don't, maybe the entire thing isn't visitable. I don't know. Morrison? Who's Morrison? Your godfather is taking you there. Noish. I wish I could go to Paris. Okay. Did Fourier call them a Fourier transform, or did someone else name that after him? I wonder. Remember the band The Doors? Oh, okay, okay. Thank you for the 3 streak. You're streaking. You know, he'll be doing the Fourier transform that I was just doing. How about that? So right now, this is just the background. We'll get Fourier somewhere in there. minus IKX. Why not? It doesn't matter. Okay. You enjoy using the floor of X and the ceiling of X. I always get scared when I see those. I just know it's going to be a complicated problem. Okay. Well, okay, I'm not going to do a straight up stick figure, but this is how I draw people if I'm not doing stick figures. It's not much of an improvement, if I'm being honest. Move your pants over. There's a lotto to be buried in the famous Paris graveyard? Really? That's a really wimpy arm. It's not like Fourier. This is not the face of this is not the face of a swole man, but his arm was a little bit too wimpy, I think. You enjoy blowing bubbles in sunshine, and I'm all out of sunshine. Whenever it comes to work in calculations, a lot of them time a range usually consistent of containing the floor of a variable or seeing of one. Yeah, I know there's some clever integrals that involve the floor or ceiling function. If you want to go to Paris, you can do it in a weekend. Lagrange might be there too. Ooh. Lagrangian is also interesting. That's not related to that's like a physics thing though, right? That's separate from Oh my god, is there a Paris? Oh, there's a Paris, Idaho. Thank you, Jed. You have my back. In just a short 12-hour and 38-minute drive in the car that I don't have, I could be in Paris, Idaho. I'm just across the state line from Utah. I'll drop by Zach's house too. What is it if you did it by transit? Will Google Maps just quit? Oh, it doesn't even do it. You could bike there in 3 days. Really? That feels short. Huh. Wait, is it like 3 days straight though? Yeah, that must be 3 days straight. Like no breaks or anything. You do modules that mix physics and maths? Ooh, nice. Sounds like my kind of thing. Ooh, we should really... He's got such like a fancy coat. I can't draw that though. I don't know. I don't know what to do about that. Thank you, Clonk. I learned from you. Wait, that's only 4 fingers. Wait, which side is his thumb on? Okay, wait. If he's... it doesn't matter. It doesn't matter. Just... 1, 2, 3, 4, 5. He's got that, like, scarf thing? Am I AI? Apparently, yeah. Okay, wait. Maybe we start with his head. And then we draw the scarf thing underneath it. Oh no. Okay. This is supposed to be like... This stuff here is supposed to be like the bottom part of his hairline. It's not gonna turn out like that probably, but... Okay, we need to get some color in here for his hair. I guess I'm gonna grab a brown. He's gonna look a little like Bob Ross, I think. Ooh. So I photo myself from junior high. Apparently my partner had a crush on me back then. Like, damn, Sean, you got no standards. Wow. Wait, so how long have you guys, like, known each other? And how long have you been together? Let's get it. Actually, let's get a gray for little scarf thing. It's got like some frills there too. I can't really draw those though. You said doing a Fourier transform. My mind immediately went to Optimus Prime. I mean, what if Fourier it is? I mean, would he be an Autobot or Decepticon? Do you guys think? I feel like he would be like a minion for the Decepticons. Autobot easily. We're in the same junior high, known ever since we were 14. Got together when you were 19. Wow. You guys have known each other for a minute. He's got kind of cat eyes, but it's okay. He's got kind of like a Mona Lisa, like kind of smile, kind of not. Oh my god, that nose. uh, I this might be my drawing. I don't know what else to add now. Can he roll out? I don't know. Yeah, Fourier transforming into Optimus Prime would be a much harder drawing. You need a coat like that in real life. It's not a bad coat. I I wouldn't do like all this like frilly stuff here, but the coat itself, that's a nice coat. I agree. Oh wait, who who is the why are there two names on that? But I'm also curious what their names are. So, unless there's any objection, I think that might be my Fourier drawing. I want to zoom and enhance. Names of his guns. J. Boylby? Dell? Boilby? I don't know. Gale? Sealp? Sculp? I don't know. Those are lame names for his arms. Okay. I'll post a picture of this in the Discord. Wait, what happened? Did I accidentally hit undo? What happened to his mouth? There we go. Give him his mouth back. Okay. Back to just plain old Fourier transforms. Resident Sleeper. Now, if I complete the square a second time, I'm just gonna run into the exact same confusion that I did before. Does Wolfram Alpha know how to do this integral? Let's find out. Minus infinity to infinity. Oh, I mean, I don't know if it's that important, but let's get... No, bad. No, wait, no. I should have done this differently. No. Okay, fine. Have it your way. Just like Burger King. Minus e to the ikx minus t plus 1 squared. Wait, no. Times k squared. Wolfram's probably not going to do it. Nope. I know it can do Fourier transforms directly. I don't know what definition it uses. Well, I guess we can make it do the forward transform and then reverse whatever it gives us. I don't know what goes where. Maybe that's the variable. Maybe this is the function. And maybe that's the variable of the function. I don't know. Nope. Okay. X? Question mark? Okay. If I invert it, aren't I just going to get the same thing back? Why am I doing this? I've lost... Okay, I lost my train of thought with this problem. What am I doing? Oh, right. The solution to the equation isn't just the inverse transform. That's the issue. Okay, so this isn't helpful what I just did here. Ugh. So I forgot, like, oh no, I made it stretchy. Okay. I just need to figure out how... I just need to learn how to do this integral again. I used to know how. Just one step that I'm confused on. What are they doing here? They're taking this thing, taking the derivative. Okay, sure. And they're making that into a differential equation. They take the Fourier transform of that, which seems it's already complicated. Thing they're doing here. I guess this is a separable differential equation. Well, this isn't the integral I was trying to do. Not polar coordinates. Oh, should I just use a series? Maybe series are the way to go. No, okay. I thought I made it stretchy again, but I didn't. Do. That makes sense. Hamiltonian dynamics. Why are my alerts? Are my alerts just not working? Chaotic Diamond. Oh, wait, the one for Math Pond never went off at all. That's so weird. But Chaotic Diamond, thank you so much for the Prime. I really appreciate that. Hope you're doing well. Yeah, a contour integral makes sense. I'm hoping to avoid. I'm just trying to. All this is just me trying to check the answer that I got to a problem, and so I'm trying not to do anything that's that complicated. I'm not really achieving that though. I'm making it really complicated. Okay, so I want to complete the square inside here. Got done with all your finals. You're taking finals at the end of January. That's a weird time. I hope they went well, though. So this thing divided by 2 squared. In high school. Oh, I mean, even, at least here in America, it normally in like December and June in high school for me at least, but it is like different. Canadian high school? Oh, I assume that Canada would be the same, but maybe not. K plus wait, that's a minus. So we want minus ix over 2 t plus 1 squared. And that came from this one. So it's plus. K minus ix over 2 t plus 1 squared minus x squared over 4. Wait. I guess like that. We start school in September, end in July. Interesting. Yeah, August to June is the normal schedule here in the US. Man, school ending in July would feel so weird. Two t plus 1 squared dk. Donkey Kong. DK. Okay, so this is something that we can just integrate term by term, hopefully, theoretically. And like, we don't need to make it pretty. We just need something we can slam into Desmos. Hey, Collar Cone. If there was one thing I was going to get tattooed on me, it'd be the power series for e to the x. Actually, no. I feel like there's better things to get tattooed on you, but that will be up there. 2t plus 1 to the 2n. N factorial. DK. Donkey Kong. Your heater broke during the big cold we had this weekend, but now it's back? Oh my god. What a terrible time for it to break down. Glad it's better now. This we can integrate term by term. What happens to it? We're integrating in K. If we integrated just x to the 2n dx, I really shouldn't need to do this out separately, but I do. Wait. That's not how that works. Wait. What am I doing? Why am I confused on this? Divide. Okay, it's 2n plus 1 x to the 2n plus 1. There. Okay. One of my sweet mate is from Peru and never had experienced winter in his life? Is Peru... Okay, wait. I need to know, like, what is the latitude and longitude of Peru? Oh, okay, it is pretty close to the equator. That makes sense. So, oh, come on. I mean, South America goes decently far south, though. So the equator... Oh, it took me way too long. Okay, so the equator is right here. It took me way too long to realize that Ecuador is probably named for the equator. But yeah, okay, so Peru is, like, right the hell there. But, like, this is not far from the South Pole. It's like, wait, okay, equator, 1, 2, wait, oh my god. 1, 2, 3 versus 1, 2, 3. I guess, okay, North America does go farther north than South America goes south. But I feel like South America still goes pretty south. Did I have any snow? No. We got below freezing for like a high. Like the high of the day was like below freezing like one day. But that's about it. Bring up Peru on Google Maps. Okay. Wait, what the hell? Maps.google.com. Just hiding the screen for a second because Google Maps is a little good at guessing exactly where you live. University closed on Monday. Wind and snows are crazy. Jeez. Okay, so bring up Peru on Google Maps. Check out the body of... Oh, is that Lake Titicaca? It is. I know of this. Everyone knows about Lake Titicaca. No, we learned about this in middle school geography class. And of course, it was middle school, so we never shut up about it. The other thing I remember from that class, it's probably like a social studies class actually, but there's apparently a dude in history named Abu, I might be spelling this wrong, Bakar. But if you say it quickly, like the first part, it just sounds like you're saying a boob. And that was enough for like the entire class to be obsessed with him. I know because of Animaniacs. Oh, nice. Every university building is closed except the Starbucks in the library. Oh, God. Dude. Oh, wait, okay. Let me actually look. So I feel like there's a couple of Starbucks on campus. Like, more than one. For me. No, oh, yeah. I think I can think of two. But I think there's even a third. Just on one university campus. Starbucks. What? There's 4. Plus a 5th just off campus. Holy crap. Let's see what Jed linked. It's like 22 more than 5-kilometer radius from the university campus. Oh my God. I never watched this. They have a whole song for it. Wow. It's educational. Okay. What's happening here? -1 to the n, t plus 1 to the n, k minus ix. Oh, wait. Oh, no. What do I do with this I? What if I just if I just give it to Desmos? Like, it should theoretically cancel out and not actually be imaginary. But Desmos might be confused and just quit on me if I give it that. So yeah, Color Cone, I'm down a whole rabbit hole right now, and I just realized it's now been an hour and I probably should just stop doing this because it's not a good use of time. But this was the original problem here. And I got an answer for it, but I was really struggling with this question, and so I was trying to check my answer by choosing a particular f of x and seeing if my answer matches up. And that's what I've been doing right now. I just chose a Gaussian. And so I've been working through how it should look if you do it perfectly. But it's just kind of a lot of work to do this. You can do it with residue. I didn't want to make it complicated, but the series thing isn't going to work, I don't think, because the I is going to mess up Desmos. You do a... I might just give up on trying to check my work, to be honest, because this is a lot. Complex integration. Yeah, it should be possible. There's no singularities, though, is there? You chose the Gaussian because I like to torture myself. Yeah, Dojo, I guess I do. So it makes it easy. Make one of the sides the real line. Okay. Power series be gone. Actually, we'll keep you. All right. Hey, Skirtle. Well, I hope you enjoy copying the wrong answer. Yeah, with respect to K. You're about to start my first calculus course in a week. Anything you should know beforehand? Ooh. Okay. This is the question. The thing I'm trying to do right now is I'm just checking my work and taking f of x equal to minus e to the minus x squared. I think it's good to do a sort of check. Is there an easier function? Probably. I wanted to use a Gaussian because they're just like such a natural initial condition for the heat equation, but it probably is better to use a different one. Okay, Gaddict, I'm thinking about what I want to tell you while I catch up with chat. Hey, Bit 101, you like to know what is a math? I wish I knew. Hey, Lucas. I made something that is consistent, but now the question is whether or not it exists. Ooh, okay. Feel free to drop it in chat. Never mind? Okay. I don't know. I just wanted to see if my first two terms of the expansion were something reasonable. I might just send it, though, because I'm getting really bored of trying to work this out. Is a math is the opposite of isthmus. Okay, so that's my first calculus course in a week. Anything you should know beforehand? Okay, the most important thing is that I think you'll be fine on this front, but just in case, usually the biggest issue students have with their first calculus class is their pre-calc and algebra skills aren't good enough, because in calculus they make you do some really annoying algebra, like you have giant fractions or just a lot of like complicated looking functions, and you have to like shuffle it around and simplify it. And a lot of first time students struggle with that piece of it. So just be warned to expect stuff like that. But if you can get past that piece, calculus is really awesome. It's what made me like math in the first place. um, it's where math starts to actually be useful, in my opinion, for things. And yeah, I guess like I guess when I'm taking class, I appreciate knowing kind of the general flow of a topic, and so in like a first semester calculus course, um, you would normally learn about limits and derivatives and basic integrals, which you don't worry if you don't know what these are. And then in the second semester, you would do like advanced integrals and power series. And these are all related to each other because you're going to start using infinity for things, or like kind of like complex analysis. I was about to do complex analysis and try and do a contour integral, but we decided against that. So you're okay for now, Raven. Advice is like kissing. It costs nothing and it's a pleasant thing to do. People have absolutely paid for a kiss before, but that's a terrible fortune. Like, advice can be really annoying if you didn't ask for it. It's not always pleasant. In fact, it's usually not pleasant. If you're asking for advice, it's because you're in a difficult situation. No, that fortune makes no sense. Lucas, I'll read that in a second. Math starts being useful far earlier than calculus. Lele, I agree there are uses for it. I'm saying useful in maybe cool is better for what I mean. Because I like that calculus unlocks, like, it takes physics from being something that you have to just memorize to something you can actually derive and understand fundamentally. And I really like that about calculus. You get to learn where things come from. Kissing booths, yeah, exactly. You will have domestic happiness and faithful friends. Well, that's just a lie. You have an idea of the first semester stuff? Limits the hardest branch here. Usually, it's the integrals that I feel like students find the hardest, but the limits aren't easy either. How strong does my geometry need to be? Because I'm pretty comfortable in algebra and pre-calc. Never really did geometry. You don't need much for your typical calculus class. There's one or two parts where it's no, you don't need anything advanced. Just basic, like the area of a rectangle is base times height, or length times width. Past that, you don't really need much. Oh no. Draw me as a cat boy. Let's read through what Lucas put. Keep discussing calculus with chaotic diamond, and then we'll Desmos heat equation visualizer. Ooh. Wait, okay. We've got a few things going on. Let me see what's up with this. Printer optimization problems. Is that something where geometry is useful? There's a lot of visual thinking in calculus in general, and sort of in optimization problems. It's not necessarily geometry. Like, it's you don't need to know that the angles in a triangle add to 180 for most problems, or yeah, like there's some basic shapes you need to know the area of, but you're not doing anything crazy. You're not doing like alternate interior angles or whatever. This is our initial condition. This might be the exact thing that we need. Thank you. This is a finite interval, but that's okay. Oh, this is like a Dirichlet boundaries. Oh, actually, that's not good. No, the boundary conditions are different, unfortunately. I think. Yeah. With only signs, that's... I would need periodic boundary conditions. That's still a cool thing, though. Not sure how flexible the f of x is. I mean, it's just a numerical solution, or it's just like a Fourier series. So it's doing everything numerically. It shouldn't matter how complex the f of x is. But this isn't the exact thing that I would need, unfortunately. I do like it, but it's something a slightly different differential equation. It's the same heat equation, just the boundary conditions being different is kind of important. Unfortunately. Thank you for even looking, though. Geometric intuition about stuff like optimization with... That's fair. Yeah. That is definitely a cool tool. Dojo. Yeah, chaotic. I mean, I guess, like I said, there's a lot of visual thinking, but not necessarily geometry. So you should be okay. Okay, so Lucas, sorry to keep you waiting. Let's read that. Then we still have a drawing to get to. You have this random number x. Oh wait, Lucas also said a second thing. Oh no, I got the second thing. You have this random number x, which is in a random number line A. A random number line? I don't know what that means, but this number has the form xan, where n is the element of n. X sub a sub n, I assume. N is a natural number. X sub a sub n plus y sub a sub m. Maybe this isn't sub, maybe the a is actually separate. Like that. Optimization uses geometry in the topological sense, not in the classical middle school to high school sense. That's fair, yeah. I have to say, I've always thought that actual thermodynamics is poorly understood by everyone, mathematicians, engineers, and engine designers, material scientists, too many spherical cows. I mean, I think of thermodynamics as being really complicated. I guess, okay, it would make sense if the heat equation counts as thermodynamics, but I always thought of of other things first, I guess, that aren't coming to mind now. No idea, but to my intuition, this helps when transforming a number to a different dimension. Zero AM. A tool from topology? Mate, I wouldn't know. Lucas, whatever you're cooking, I'm not smelling it right now. I don't understand any of this, I don't think. I don't know what you mean by random number line. And I don't quite know what this XAN actually means. They just did an experiment that showed that 1,000-year-old building design with shitty R values was easier to keep warm. The highest end technology building with amazing R values. Oh, is R like like the coefficient of heat transfer or whatever it's called? Or like some measure of like insulation? Seen the heat equation so many times to prove hard theorem in topology? Really? I can kind of see that, where it's like deforming your initial condition into a flat surface. Oh yeah, chaotic diamond. Like, I remember like looking at the questions that you've worked on before. I think you're gonna be fine. And someone who's taking calculus for the first time is like, that's perfect to get help from like the Twitch math community, because like I feel like that's like the thing that I'm best at for tutoring personally, and like pretty much all the other math streamers are going to be really good at explaining the concepts there too. Like there'll be plenty of help to go around if you ever feel like you need it. A is like a dimension, or like how R is a different number line than the N number line. So it's like a set of numbers. It's not just insulation that matters, it's thermal mass. Our values are insulation. Okay. Dentist talked about calculus the other day. Ooh. What was he talking to you while his hands were in your mouth? Because I've definitely had like a dentist who would do that, and it was really annoying. Because like, how do you reply when someone is poking around tools in your mouth? Oh yeah, chaotic diamond. Absolutely. Yeah, I guess to them being a set of numbers. So what does it mean to have x like times a sub n? Because, or if I'm interpreting this notation right, they always do that. Yeah. The last time, well, okay, yeah, the last dentist I went to didn't. He seemed like he really didn't want me to be there, and he was just like not being gentle, and I was like, that was not a good experience. But at least he wasn't talking to me and asking me questions. Like maybe he seemed like he was in like it. Maybe he was in a rush or something. It's like a notation. So maybe it's more like you meant like that. Like x is in a sub n. Dentist calculus is just hardened plaque. I don't get it. Sorry. There's a pun there that I'm not figuring out, I guess. And so I guess I would interpret this statement that you said here as like, taking the union of a sub, like a sub n plus m is a sub n union a sub m. I don't know. Like maybe you're thinking of something different, but this feels like a different way of talking about sets, maybe, and like whether a set is closed. Calculus equals Tardar? Really? Oh my, I just Googled Tardar and that was a bad idea. Because I got pictures of Tardar. Oh my, wait, yeah. Okay, If you don't want to see a picture of gross teeth, look away from the screen for a little bit, I guess. Because I want to show what I'm looking at, but like it is a little bit gross. I'm gonna show it. I never knew that calculus is also a dental term. You taught me something. Stream reported? No, I mean, this isn't against the rules. I just don't want to gross people out. Like, some people are more squeamish about this. So. Usually from bad hygiene and smoking? That's fair. Calculus means small stone? Huh. Why was that? Use stones for mathematical purposes. Okay, what's the etymology of calculus for math? You don't. But if A3 includes A1 and A2, it feels like you sort of still are. Etymology. Small pebbles still persist in medicine. Is that a kidney stone? I don't know. Pebbles used for counting out distances, tallying votes, doing abacus arithmetic. Huh. Bentham's philosophic calculus? Ethical calculus? Huh. Wait. For calculating the degree or amount of pleasure a specific action is likely to induce. An ethical hedonist believe the moral rightness or wrongness of an action to be a function of the amount of pleasure or pain that it produced. Okay. These stones were weight indices back when smartphones didn't exist. What do you mean when smartphones didn't exist, Skirtle? Pretty sure cavemen had iPhones. It's not really a set, it's entirely a new number line. Well, a number line isn't like a defined thing in math, aside from being a set of numbers, is the issue. Skip the last comment about A infinity. I don't know. It okay. You have a different definition for a number line than I think of it, I guess. Yeah, it seems like a color cone. Well, yeah, but it's like a number line is a set of numbers, though. It's just how we represent that set visually. I think I'm gonna just drop this attempt to check my work. Like, is there a better initial condition that I could use? I mean, no matter what, even when I chose like a piecewise, like just like a box function or something, I would still have to integrate that, and that's annoying. So maybe I'm just gonna drop it. Even though I really, I don't know. This is worth at least partial credit, even if I'm wrong, right? Okay, so how did I actually solve this? Because I'm gonna have to do the same procedure with the second problem. I got the Taylor series of that. Okay. So this is the next problem. It's the exact same thing, but for this differential equation, and you have a slightly different integral. Sure. What I'm going to do is I'm going to split off the e to the minus k to the fourth t in front. And then we have e to the ikx f hat k dk. And so to do an asymptotic expansion of this, I'm going to find the Taylor series of this thing here, the first two terms of it. Yeah, that was my problem, color coding. So we've done many examples of stuff kind of like this. And so specifically, I thought this one was going to be like we were specifically doing one with like a Gaussian. Seriously, to give you the little O. It gives you the little O of something. Probably whatever you're expanding around. I honestly I'm really not good at this, so I don't really know. Should you variable like 1 over x? I don't know. So like I went to office hours yesterday and I talked to the professor about it. It turned out not to be that good of an idea because she hadn't worked out the solutions to the homework yet for herself, which feels like I don't know what to say about that, but this is basically she was trying to figure out on the spot, and this is kind of like the conclusion that she came to for like how to proceed. So I was trying to basically split it up into an integral in the neighborhood of 0, and then an integral that is outside of this neighborhood that should be insignificant. But she said that's not necessary, and instead follow procedure for the last question, which has to do with getting an asymptotic expansion for ERF, the error function. But the thing that I was confused about with this is that the thing that's moving is the bound of the integral, not a parameter or anything inside the integral. So it just seems like a different problem, but I just kind of blindly still tried to do it, and we use a series for that. Oh shoot, you redeemed a drawing. I forgot about that. I mean, I already worked this problem out, and I know that I'm right because I checked it. I did not need to take the derivative of the error function, though. Maybe? I don't know, but like for part A, which I got the right answer. I just used the power series for the Gaussian. I bound the remainder and showed its little o of x to the n plus 1, and then I integrated the series term by term, and that was good enough. Maybe that should technically be the tilde, the twiddle. Well, that's not infinity. I'm going to say equal. Who cares? Yeah, I was just showing that because the professor said to follow the procedure for the error function, and I think for part A is what she meant, because part B just seemed really different. For part B, okay, you're asking about part B. I split the integral up into two pieces, which is what we did in class for a similar problem. One from 0 to infinity, and then subtract out the part from x to infinity. The first integral is just half of a Gaussian integral, and it's an even function, so that's easy. The second piece, using integration by parts, you can figure out a pattern and get a series out of that. I wrote it here with this like f sub n type of thing. You don't have to do this, but basically if you integrate by parts again and again and again, a series kind of pops out, and you can summarize it into this pattern here. So I don't know, you just integration by parts, the series just pops out at you. And you can again bound the remainder. Ignore the type text. This is me hastily typing stuff down during office hours. This is actually the TA's office hours, because I've been to office hours twice for this homework, and I might go a third time. But yeah, so I'm just gonna hope that this procedure is correct. It at least got an answer, and none of my other procedures I was able to, like, I got stuck with all of them, so. So the Taylor series for this thing, we're expanding about k equals 0. Okay, and so that's another weird thing with this, is that I'm taking a Taylor series about k equals 0, but t is going to infinity. So I don't know what to say about that, but if you plug in k equals 0 here, it's just f hat 0 plus f hat prime 0 times k dk. But no, like, that's not necessarily necessary, because the Taylor series is in k, not in t. And this f prime is a derivative with respect to k. And you can get from this definition that it's minus ix minus infinity to infinity to the minus ikx f of x dx. The other nice thing is that expanding about k equals 0 means that this e term factor disappears, and they just become constants with respect to this integral. So I can actually even do this. So yeah, I might go to office hours tomorrow because it'll be the TA's office hours, and I might ask him about this approach for this problem, but I've tried this hopefully successful attempt at number 6 right here. I had 5 other attempts before this of doing other things, and none of them panned out. So if it's not what I got, I really don't know. And then number 7 that I'm working on here is literally do the exact same thing. So yeah. Ooh, there's a nice change of variables here. Well, yeah, I guess. What do I do about you, though? Show direct product of semi-rings? Why, I don't know what the hell that is. Direct product of semi-rings. Okay. See something very non-continuous? Okay. Okay, maybe, Lucas, I don't... Maybe I learned about product subgroups at some point. I don't remember how these work, though. My algebra is very weak. So wait, what did I do? Huh. Am I gonna get a different gamma? Is that the only difference? So how did I work out what the second term is? I don't even see my work for that. I don't know. For t greater than 0, function is very smooth effective. For t less than 0, Really? I've never even heard of doing it with negative time. I'm gonna work just on this integral on its own. Oh, wait. Oh, ew. No. This is an odd function. You, my friend, are 0. Right? That's probably what I did with the other one. No? Is it? That was even. I don't know. This is definitely odd, though. Wait. Why did I go to the second derivative? Oh, right. That's why I went to... Okay, yeah, okay, yeah. I forgot. In the last one, I went out to the second derivative. Because of that issue with being odd. The normal solution for the equation is a Gaussian-like function. This condition is a Dirac delta function. Oh, and that's how you get the weird stuff for negative time? With a Dirac delta initial condition? Something like that. Oh. Okay, never mind. That is weird. Duh HD792, thanks for the follow. Why are my alerts not working? Well, welcome in. This is gonna bug me. Like, what's wrong with my alerts? The power of power? Like, what do you mean, how? That's what I'm testing. Wait, so that works. Why isn't... So that was just like a test alert. I don't know why they're not playing regularly, though. I don't know. So yeah, I don't know what you mean, like, how is the power of powers? Like, maybe you're talking about tetration? How it solves a power. Well, what is it? Um, okay, so if I just, and I'm happy to keep on talking about that to HD. I'm just trying to understand what the question is, but in the meantime, I'm gonna keep working on this, just to have something to do. 4k cubed t dt. We'll just see what this u sub gets us for the first integral. I'm going to take advantage of it being even. Ooh. U over t to the 3 over 4? It's a little ugly. That might be okay, though. So we get e to the minus u, u to the minus 3 over 4 du. And hopefully this is gamma in some way, shape, or form. I think it is. Always forget the definition of gamma. Here we go. Yes. So if we have a minus 3/4 there, this must be gamma. Let's just write it down. Gamma of z is 0 to infinity e to the minus t, t to the z minus 1 dt. So if this is a minus 3/4, that means z must be positive 1/4. Okay, in other words, a power of powers is a number raised to any number in parentheses. Oh, okay, so I thought you were talking about something more complicated. Sorry about that. Thank you for giving it an example. So you have 5 squared squared, and you're wondering like how to simplify this. The rule is that when you have this type of situation, the powers multiply. So when you have 5 squared squared, you'd have 5, and then you do 2 times 2 is 4. Hey, Broral. So you could have also, I guess, done like you could have done the 5 squared first inside the parentheses to get 25, and then square that. It'll come out to be the same thing, these two things, but yeah, that's the answer. Like you just multiply the two numbers. No worries. Thank you for explaining what you meant to me. And in case you have more questions, feel free to come back here. But also, if I'm ever not around and you have a question, there's a whole little niche of us math streamers who do stuff like this. So whenever I see a new person, I just like to let them know that this niche exists on Twitch. And I think even on this list, e2the2pi is streaming right now, and maybe others too, but yeah, welcome in. Okay, so we figured out the first integral. We need to figure out the second integral. So we're going to come down here. That's too big of an arrow. This one is also even, so I'm going to consider 0 to infinity. K squared e to the minus k to the fourth t dk. Donkey Kong. The thing that I don't know what we're doing is like, I don't know how t to infinity matters here. Like I would have done the exact same thing if t was going to 0. So I don't know if I'm implicitly assuming t is large here at some step and not realizing it. So we probably do the same substitution here. We just get a different value of gamma. I mean, let's also use that down here too. Just draw an arrow. Okay. Which part is us? Oh, just the problem was to do it as t goes to infinity. And I don't know where I'm ever using t going to infinity in my work. I assume I'm implicitly doing it somewhere. But as far as, like, I've never knowingly put any conditions on t here. It's like, for all I know, this would be just as valid for t going to 0 instead. But maybe some step that I did kind of assume that t is large and I just didn't realize it. So we have a k squared here, and then a k cubed from the sub. So we're going to have just a k there. How do I get from the first line to the second line? With that u sub. At the top? Oh, here? I expanded this in a Taylor series. I took the first 3 terms and then truncated it. A Taylor series about k. K equals 0. Yeah. Because the question is just the first 2 terms. No, I won't, Walter. So you need f to the k fast enough? Probably? But yeah, like, t is nowhere inside of this. So, I don't know. Okay, so just k, I guess, is this to the 1/4. It's going good, Walter. Thanks for asking. How about you? To the 1/4. So that's t to the 3/4. E to the minus u to the minus 1/4 du. Oh, well, thank you, Walter. I appreciate it. Then we have gamma again. But this time, if it's negative 1/4 there, then that z must be 3/4. And I don't think we can relate gamma of 3/4 to gamma of 1/4. In the problem before, I happened to have gamma of 1/2 and 3/2. So I wrote the 3/2 in terms of gamma of 1/2, but they're not separated by 1 this time. Although gamma does have all sorts of identities. Maybe there's a different one. I'm not going to bother though. It's not really important. Okay, so now we return to this line and we bring our constants back. So we need this multiplied by that, but also stick a 2 in here because I changed the bounds of the integral because it's even. Arrows everywhere. Arrows all around. So that's 1/2 pi. I'm going to multiply it by 2 to account for the evenness that I used. So 1/2 pi. Now f hat of 0 is this, but plugging in k equals 0, so the exponential goes away. And then the result of the integral was that. So actually I'm going to take it, I guess we'll scooch the integral over. 1/4 pi t to the 1/4. Scooch it over more. Gamma of 1/4. Yeah, that's the first term. The second term. So that's 1/4 pi times 2 will be 1/2 pi. We need to work out f double prime of 0. I did f prime there. F double prime, we're just going to multiply by another minus ix. So it'll be minus x squared. So change that to minus. I'm doing a master's in math, Walter. Wait. I think I did a stupid. I did. Okay. The derivative with respect to k of f hat k kx f of x dx. Thank you for the kind words, Walter. So this integral is an x, and so I'm just gonna bring the derivative inside and not worry too much about it. The thing that I did wrong was when I took the derivative of e to the minus ikx, I brought the x outside the integral, and that's just certainly wrong. And I messed that up in the other problem too. Hey, famished. Not bad. How about you? Quinter. Hell yeah, dude. Hope you're doing well. How's the cherry pie? I don't have ice cream. It's way too cold for ice cream. It came out pretty good though. There's some things I could have done better, but for having not made too many pies in my life, it came out pretty good. Can't complain. I think I can just simply take this x squared and drag it in here. It should never have come outside. I'm from America. Thank you, Quinter. Yeah, it's maybe like it's somewhere around like my fifth pie that I've ever made, and they're really finicky. So there's a lot of things that can go wrong, but overall, not like it was pretty decent. What was I doing here? Oh God. Oh no, did I do this? I think I just made a bigger mistake than I realized. Well, wait. Ooh. Oh crap. I messed this up. I didn't do my Taylor expansion correct. Wait, did I? No, I did it wrong. Okay. Um I go to University of Washington. Okay. We're gonna do a new attempt. I have to go back and fix the last problem too now. Okay, so the thing that I did wrong is I was Taylor expanding this as a unit. I was taking my derivatives incorrect. I was taking the derivatives of just this to figure out the coefficients, and that's wrong. So here we are. We're doing a product roll. E to the I k x f hat k prime. And if we evaluate this at 0, we get ix f hat 0 plus f hat prime 0. Cheesecake for your birthday in 2 weeks. Ooh. We got a soon-to-be birthday boy. Cheesecake is a great choice. Cheesecake is probably my favorite dessert. Oh, wait. Oh, so maybe I don't need the second derivative. Okay, so the first term, we just take this, plug in k equals 0. That's how Taylor expansions work, I think. The second term, this is the constant times k. dk. So no, we do need the second derivative still. Because this is all constants, so they don't matter. In k, e to the minus k to the fourth t is still an odd function in k. So that's going to zero out, and we still need the second derivative. Okay. All right, this is fun. We have two product rules now for the price of one. Minus x squared e to the ikx f hat k plus ix e to the ikx f hat prime k. Second product rule. Ix e to the ikx f hat prime k plus e to the ikx f hat double prime k. K. And we can take k equal to 0 if we want, if we desire, and simplify. Minus x squared f hat 0. These two terms combine. Okay. Now the important thing to remember is that these f hat primes do not simplify like I hoped they did. They just have to be their own things, and that's okay. Minus x squared f hat 0 is 2ix f hat prime 0 f hat double prime 0 for 2 k squared dk. Well, we still have basically the same integrals now. So our work wasn't all for waste. It's just the constants that are different. We still have k squared e to the minus k to the fourth t. Well, that's good news. It's a good thing. Okay, so let's figure her out. 1 over 2 pi f hat 0. And so just from this integral, we want 2 times this result here. I guess we can even copy it. And make that a 2. Then we have this bad boy times that bad boy. This will be a lot easier with power of copy and pasting. So I like doing homework digitally. And then we have k squared e to minus k to the fourth t, which we need to do 2 times this result. Now we simplify. 1 over 4 pi t to the 1/4 gamma 1/4 f hat 0 is that. Is there an easy check we could do here? Like, for large t, if we have an odd initial condition, this is 0. And so for large t, the integral, or the solution should 0 out. Hopefully that holds true with this other piece here too. The I seems like a problem. Ooh, it won't be a problem. That's magical. Because if this is f hat k, then f hat prime k is negative I times integral infinity to infinity x f of x dx. And the mistake I made earlier is I put this x out front. And this is still an odd function if f is odd or whatever. But yeah, and so this minus I is what is the magical part, because it'll get rid of this I here. So there shouldn't be imaginary things in our final thing. So we want -2. So f double prime, oop. We're gonna have 2 minus ix's get pulled out front. So it's gonna be minus x squared in front. Wait. It'll be just a minus sign. The x squared stays inside. Don't make the same mistake twice. That does not... Wait, even times odd is odd. Okay, we're good. And we can factor out these negatives. What an expression this is. 8 pi t to the 3/4. Gamma of 3/4. Okay. This is allegedly my answer? I guess so. All right, let's go fix the last problem. Ugh. It's this step here that is disgustingly wrong. This work should all be the same, though. Yep, okay. And so the only thing that needs to change... Yeah, I need more room. Over 2. Okay, there we go. And then... I guess I did this part mentally. I'm gonna work it out separately because I don't trust past me to actually to do things right. I don't trust current me to do things right either, for that matter, but here we are. K squared e to the minus k squared t dk. I guess I did a tau sub here. Okay, so we have a k squared here, and we're going to divide out one of those k's from that substitution. So we're going to have a root. We're going to have a tau to the minus... a tau to the... I'm doing too much in my head. The 2's cancel. We get just 1k, that is root tau over t. And that's a t right there. So 1 over t to the 3 over 2. Enochian, thank you. Hope you're doing well. So we got just a k to the 1. I already accounted for the t. So it's tau to the 1/2. E to the minus u. Tau d tau. How's the math? It's going all right. I'm just kind of plowing my way through this problem. I thought I had it solved, but I just realized that I made a mistake, and so I'm going back and fixing it. But theoretically, I'll have this homework assignment done once I'm done with this. Maybe not correctly done, but I'll have an answer for all the problems, which is something. When's the... 1 over t to the 3 over 2, and that should be gamma of 3 over 2. So actually, I guess we did that one okay. Go back to math again. You want to do really long calculations and problem solving? Oh, I don't. This problem is really long and I'm suffering through it. I'm going to keep it as gamma of 3 over 2. Who cares? The first term should have no mistakes. Yeah, the first term should be fine. Makes you feel productive? That's fair. Definitely feel like I've accomplished something by the end of doing problems like this. If the problem feels like meaningful in some way, which this one does enough, I guess. X. And then we have t to the 3 over 2 gamma 3 over 2. Does that look vaguely like what I got down here? Suppose so. Okay, then that numerator becomes the same thing as down here. Why reinvent the wheel? Update the denominator. 4 pi t to the 3 over 2 gamma 3 over 2. And I guess that's my answer. Ugh. And see, the only easy thing I can think of to verify my answer is to let f of x be an odd function, in which case this does zero out over a large enough time. So that part is consistent, but that's the only easy check I can think to do here. Oh my god. Get some water. Okay, so God, this is 18 pages. Well, one of them is a drawing. This is 17 pages of scratch work for one homework assignment. It's appreciating my work right now. Okay, I think I want to give this assignment a rest because I think the only thing left to do would be to LaTeX it up. I don't know, like, I might want to go back to office hours again and verify that I had the right idea for this problem, these two problems that I just did. I don't know if I want to go through that trouble of going to office hours, but yeah. I don't know. What we can do, though, is switch gears to a different class. So this is for my data analysis class. We have a sample image here, and we are using wavelets to basically detect edges in the image. So like the edge between the sky and the dude's jacket, or with his hair in the sky, or whatever. Like whatever, there's an edge in the photo, like a sudden change in color from white to black or vice versa is considered an edge. And they basically kind of like when you do this like wavelet transform, those edges are going to correspond with kind of like spikes in the data, so you can just filter out everything that's not a spike and keep just the edges. You're getting a cheesecake stream. I don't know, but cheesecakes are like, they're really quick to assemble. It wouldn't be a very long stream. I mean, they take a long time to bake, I think, too, is part of the issue. It's been a minute since I made a cheesecake. But that would be a harder one to stream, I think, than a pie. Wait, there's a sauce for Biscoff cheesecake? I thought it was just like the crust with Biscoff crackers. Let's see. piesandtacos.com. That is a little bit dirty. Pies and tacos. This does look good. Is that just caramel? Oh no, if it's caramel, I'm not doing it. I've tried to do caramel a couple of times. It's never worked out. Oh, it's just melted cookie butter. Well, that's a lot easier. Oh, and that's cheesecake's an even longer to cool than pie does. Like it's literally like overnight. It was pretty good, Raven. It could have come out better, but for not having made too many pies in my life, it was pretty good. How hard is this one? 250 grams Biscoff. A third a cup of butter. A stick of butter is a quarter of a cup? I want to say? Or is it a half cup? I don't know. So worth the almost fire? Oh, absolutely. I would have actually burned my apartment down for pie. A stick is a cup? Really? I'm getting butter. All right. I'm now a butter streamer. Hardly know her. Yeah, half a cup. Come on, Skirtle. Wait. Where is it? Right underneath my finger. half a cup. Or above my finger, not underneath. Oh, over here. Ugh, I yanked my headphone cord and I dropped my headphones. I do that like a million times a day, though. Looks so fancy. Trader Joe's is fancy but cheap. Correcting myself, you doofus. Well, you know, Skirtle, I had to rub it in your face. Just you correcting yourself isn't enough. Also, it's shrimp time. Ugh, it's like a half shrimp. Rub butter in my face. You know, I'm sure. I mean, no. I would say probably someone is into that, but that's like guaranteed. Like you're just gonna give yourself acne, right? Pretty sure it's a kink. I mean, a kink? Maybe someone just enjoys it because they like butter, but do they get off to it? Butter? Oh no. I mean, yeah, it's true. We can get rid of that. We can get rid of that. I mean, I mean, this sauce is just melting cookie butter. I could do that in a pan, I guess. Sorry, Raven. Stuff is also easy to mess up. I mean, the sauce doesn't seem easy to mess up, but like cheesecakes themselves can get messed up for sure. Oh, is this a no-bake cheesecake? It is a no-bake cheesecakes are the worst. 2-ingredient Japanese cheesecake. What is that, yogurt? It is yogurt. What? This isn't cheesecake? Okay. I'm gonna get mad if I keep looking at that. Okay, anyway. It tastes like cheesecake, but healthy. I have a hard time believing that it tastes like cheesecake. Just yogurt and Biscoff cookies. There's no actual cheese in it. Why did I put that at 0.4? Or maybe something weird happened with it saving. Oh. Restart it. Come on. Okay, and then run all. Okay, so yeah, basically, ooh, wow. The wavelet transform of this image will spike when there's a sudden change in color. My alerts still aren't working apparently, but Curios, thank you for the follow. That's annoying. The wavelet transform gives you, I guess it'll detect like spikes like only horizontally and only vertically and only diagonally, but we can add these all up. and only keep the ones above a certain value. And that's how I get this image here. And the next step in this process is to add noise to the image and then try to do the same thing. It's apparently not going to work as well. So we have an example of a noisy image here, or the same image with noise added. And I think I want to make it more severe. I want to make it noisier. There we go. Just to make it more obvious what goes wrong. Image, noisy image, DWT. It's equal to noisy. Should maybe just noisy DWT. So this is doing the wavelet transform, and then we need to add up all the coefficients here. Noisy binary edge map. Ooh. So yeah, that's not ideal. Let me tell you. If we had a higher threshold, would it have gone better? I don't even see the shape, to be honest, so probably not. Why did it get worse? What? This is doing the opposite. Wait. I don't know what I'm doing. Hey, Doomwood. Okay, wait, no, okay, this does make sense. Maybe. Let's try it with less noise. That's not too bad. Finally finished the stats syllabus. You started banging out past papers. We're starting to like stats? Hell yeah, Doomwood. Stats is awesome. Glad that you're enjoying it. Enjoyed it more than the mechanics. Yeah, I personally am not a fan of mechanics, so harmonic motion was BS. Yeah. So we can deal with noise. Is to look at multiple scales, whatever that means. Is this what I want? Multi-level decomposition? Maybe I just want mode. I don't think this is it. Do we have an example of this? I don't think we got an example. What is wave deck versus wave rec? Oh, inverse versus not inverse. Okay, well. Oh, reconstruction. Oops. DWT max level? Okay, what is DWT max level? One, two, three. This is probably what we want. Um, oh. No, geez. Sorry. What time even? Oh my god. It's almost 4:20. Get ready to make a wish. Can level be a list? No. Wait, can it? So if you give it level 3, does it give you like 1, 2, and 3? Okay, what is the max? Okay. Wait, SWT max level. Well, DWT max level. There we go. The maximum useful level of okay. I kind of want to get into Python now and get to familiarize myself with the language and syntax. What do you think is the best way to do that? Do you have a specific goal with programming? Like, do you want to make apps? Do you want to like do math with it like I'm doing, or maybe you don't have a specific goal and you just want to generally learn programming? Leaning towards data science. Okay, so that's basically what I'm doing here. Maximum decomposition we're routing out here. Yeah, K-parse. This is for Wavelets, which it's like a Fourier transform, but like locally, so you can see the different frequencies in each part of your data. And it's like the maximum kind of frequency that you look at. Okay, so yeah, so definitely like the two most important libraries you don't want to be aware of are NumPy and SciPy. For a lot of like data science stuff. NumPy is probably the most important one. And for an actual resource, I'm sure there's a lot of them out there. So it's NumPy. I say I don't actually know. I've always said NumPy because the P is capitalized, so it looks like Python. So I pronounce it like Python, I guess. What do they do and what do they consist of? What do you mean by a so-called library? Okay, so you're right, I should have started with that. So Python, when you Python by default includes certain things, like a certain like minimum number of things to like get you going with programming stuff. So like you can have lists, you can have variables. It provides you some basic math functions like sine and cosine, things like that. If you want to do more advanced things, you want to start using libraries because they build on the tools that Python gives you by default, and they can save you a lot of time from having to build them for yourself. So a library is basically a set of code that someone else made that you're including in your code to save yourself time. A library set of ready-made functions you can import, someone else program them, but you can download them, put them to use. Exactly, as Kpars says. And so it's like Python's by default, Python's ability to handle like lists of numbers is not great. You can do some things with it, but it's not that powerful. And when I say powerful, I mean doing simple things mathematically can take a lot of lines of code, like matrix multiplication, for instance. So what NumPy does is like the thing it does best, I guess, or the main reason people use it is that NumPy lets you deal with matrices and vectors, and it implements all the math stuff for you. So all you have to do is like call NumPy's matrix multiplication function with two of your matrices, and it handles everything else for you. Whereas Python by default doesn't have anything like that as far as I know. Get the library part now? Okay, awesome. And so yeah, if you want to keep things easy for yourself, and not have to deal with installing libraries specifically, you could install something called Anaconda. It's what I have, and it's like it is just so many Python packages packed into one. It's like it's kind of too much. Like it's basically like bloatware with how much it has, but it is easy. So I think it includes Python itself too. So if you really don't want to deal with like installing packages individually and managing them, Anaconda does provide an easy way of doing that. But it also installs a lot of things that you probably don't need. So it's like a trade-off, but yeah. So yeah, if you really just want to get started, that's probably a good call. Yeah, exactly. With R's tidyverse, maybe. I'm not too familiar with R. Okay, through installing random bloatware. Okay, good. I am too, evidently. So yeah, if you install an Anaconda, just like a place to type your Python, like I have a VS Code here. You might need to make VS Code aware that of like where your Anaconda installation is, but aside from that, like that's all you need to get up and start running Python code. So data cleaning and processing packages basically become standard, so they all got grouped up. Oh, okay. Yeah, that sounds like Anaconda then. Yeah, VS Code is what I use. I'd like to hit the ground running for my freshman year of college. What do you think the best thing to do in the summer for Python? Just try and accomplish a project, big or small. Well, small is better. If you can locate a copy of it, the book I'm using in my class. Oh, which one is it? Oh, I don't know which one it is. Maybe it's this one. There's different editions. That's what I was debating right then. This one has like a bunch of exercises that you can do as like projects that are pretty interesting. So if you just go in like chapter 1, like what's at the end of chapter 1? Oh, there's no problems in chapter 1. Okay. Let's go to chapter 2. I mean, you could also replicate the things they're doing inside of this chapter. Really? Where are the... I promise there's exercise problems in this book. I've had to do them for homework. Unless I have the wrong edition. Do I have the wrong edition? Oh, the math starts off easy. It escalates. But like if you stick in part 1, it's like linear algebra. I guess this might be a little bit advanced. Part 1 isn't that bad. But like linear algebra and like first year calculus. Just like solving systems of equations. That's easy? Okay, yeah. It gets crazy, which is why I hesitated. Because it goes into like PDEs, and even machine learning, I think. So it gets crazy in part 2 and stuff, but part 1 is manageable, I think. Oh, good. Yeah, I guess and I can vectors. Maybe this is the edition of the book that I meant. Ooh. Wait, this is a different book. I don't know. Okay. Sorry, I've apparently confused myself here. Oh, I need to catch up with K-Pars's comments too. Okay, this is the other edition that I have, but maybe it's not actually different. Oh yeah, so see, this has problems in exercises. So it's just, I had the wrong edition before, I guess. Okay, there, yeah. So even in chapter 1, like, these are little things you could program and trying to just like take problems from a book like this or this book is probably a good idea. They had like filtering and merging and piping and vectorized functions to apply a whole function over a list. Oh yeah, so that's what NumPy does too. VS Code is what's called an IDE. Right, you can write programs, execute them, debug them. Language agnostic, which is nice too. Oh, no. You could not finish this book by the end of summer. No one could finish this book in one summer. No hate towards you. But this book is... Or this version of that book is 21 chapters. And it gets into some really advanced machine learning / partial differential equation stuff. Like So some pretty like heavy stuff that takes a long time to understand. Chicken. Oh, nice. So yeah, I'm sure there's like plenty of books if you just like do a general Google search. Like, for textbook recommendations, I would look at like Reddit and Stack Exchange and just see what people say about a certain textbook. And then you can always just like put the name of the textbook space PDF in Google and see what it comes up to. If you don't want to pay for things. Procrastinating writing statistical analysis plan. Ooh, okay. Second book hell. That's fair. Yeah, I mean it's best to just like choose a book and like just go with it. For sure. Do my own share of procrastination. It's a tie that binds us all. Yeah. Yes, that sounds good, Doomwood. Uh, it probably doesn't teach you that much programming. Control Shift T opens. Okay, yeah. Let's see. I think this book does emphasize the math more than the programming. Which would be a downfall, because like it sounds like you don't know any programming, or maybe I'm assuming too much, but yeah, this book kind of gets. It's more about the math. I don't think it's going to give you like a first time introduction to programming. You might want to just look at like a regular YouTube video for just like a general Python introduction. There should be a bajillion of them. It's a really popular language. But yeah, I don't think this book will do it for you. Oh wait. I guess they do. Kinda. So like, this looks like the fundamentals of programming. It's like, learning what a for loop is something that you should learn in pretty much every language. So that's like a fundamental thing. If then statements also. So I guess it does give kind of an introduction. It's probably not going to be enough, though. I haven't watched many Python introduction videos. I don't have a specific one. I would just go with like a highly viewed one to be honest. It's such a popular one. I'm sure there will be a very like good one that's become popular. Tutorial packaged in Python to properly walk you through examples? Probably. And R there's Learner, which opens a little tab where you work through mini examples. Oh, that's cool. Do you have a favorite intro Python source, but they're all over? Yeah. R is another programming language. I use it for statistics. I don't know if it's dedicated to statistics. I think it is. R programming. Yeah. So it definitely is for data science. I statistics would be in this case like it maybe has like a different slant of data science, but it's also like data sciencey. And R is like Python is a general programming language that you can use libraries to make it into a data science language. R is just dedicated data science language. So it comes pre-installed with a bunch of stuff like more than Python has to like get you going. Oh, it's also a general language? Okay. Fair enough. I've only played around with very basic R, so I don't know that much about it. But yeah, I definitely think of it as specialized. It may technically not have to be specialized, but yeah. You can build apps and everything? Okay, fair enough. As fast as okay, yeah. I've even heard that with Python. Like uh last quarter for my math biology class, we had to like do a project that pretty much involves coding in some way, and I heard some other groups criticizing Python for being too slow to run simulations, and they had a lot better success with Julia. We asked whether we could, but not whether we should. What was I doing? I was trying to figure out this DWT max level. Very high level scripting language has its inefficiencies. Yeah. How dependent is data science and machine learning on software engineering skills? Not. They're related, but not that related. Software engineering is very much about organizing a large amount of code, and there's a lot of it has its own distinct concepts to learn about how you organize code. But for data science, you usually have like your code isn't that long. You're just implementing mathematical algorithms or techniques. So like a software engineer like would need to manage like hundreds of thousands of lines of code, and like a data scientist was just going to do like in the realm of like hundreds or thousands if it's a big project. But there definitely is like some overlap, to be fair, but not that much. And a big part of that is the stuff like NumPy that takes care of the software engineering stuff for you. If you build a computer specifically for a machine learning algorithm like some billion-dollar quantum finance company, then maybe you usually just ask it to run and fill out the arguments and wait a few minutes. Yeah. One of the colleges I'm looking at offer some software-oriented electives. You know, it wouldn't be a bad idea at all. It wouldn't be directly, depending on what it is, it might not be directly relevant, but it is interesting stuff in its own right, and it'll kind of generally make you a better programmer, depending on the exact class. Yeah, I guess they you might need to be a little bit cautious and see if you can figure out what language they use. Yeah, I can look through them quickly. Um, depending on the type of class, they might use a different programming language like Java or C++. And if Python is your first language, it's going to be a little bit rough to switch to something like that. Just because Python does a lot of things for you that other programming languages don't automatically do for you. So that would be a challenge, but okay, I see you posted it. Hey Slim, how's it going? All right, so these are the electives that Doomwood could potentially take. If you're interested in data science, algorithms would be a great one to know. These fundamentals of computing classes, potentially, assuming they're just general programming classes. Okay, so yeah, you have to take the fundamental one, 6 optional ones. So you have to do 1001, 1101. Okay. So you have 6 more to choose from besides these 2 here. So yeah, analysis and design of algorithms, that's a good one to like kind of up your general programming like game. Like you can write shorter code if you're good with the stuff that they'll teach you there. DSA are 2 separate classes? Okay. AI, if you're into it, is definitely great to know for data science, neural networks. I personally would be interested in like biostatistics or quantitative biology. Those will be somewhat relevant to data science too. A lot of people told me to look into computer vision, neural networks, and big data systems. Yeah, I kind of skipped over big data systems. That could be a good idea too, though. I was kind of assuming that was more like a database class, which isn't necessarily relevant to the computing portion, but that might be something else that I'm just not thinking of the right thing. Machine learning engineer, like a general data scientist? Okay. Principles of marketing is on here? Oh yeah, it is. That's kind of weird. Discrete math. Kinda. I like differential equations and numerical methods, but you might not be. I wouldn't do math logic. At least not, at least like, not unless you're interested in it for its own sake. Yeah. That's what offers some foundation for machine learning. They're kind of different. Counting for bias, ML is about predicting. Okay. So yeah, I mean, so you're choosing 6 off this list. If I were to choose 6 for myself and I was majoring in data science, you're not a biology guy. Okay, so I'm not gonna do those then. Actually, so yeah, so I won't choose for myself then, but like the ones that jump out to me are analysis and design of algorithms, fundamentals of AI, potentially big data systems, depending on what the exact subject of that class is. If it's just database design, you could probably skip it. But if it's something else, then maybe. So how many am I saying? I said algorithms, AI, neural networks, Computer vision could be cool. I just don't know much about it for myself, so I struggle to like recommend it. That'll leave 3 more. Oh yeah, okay. So the big data systems is data cluster architectures, scheduling and resource management, big data sets such as Hadoop, HDFS, Spark, big data processing techniques such as MapReduce. Ooh, that actually does seem like a really relevant class. I was thinking of the wrong thing. Yeah, I would put big data systems on the list to take. Because that does look good. Yeah, like the names of college classes are not always great. The main BIOS just the data you put into it, like risk factors for heart attacks, such as calculating risk is universal. Oh yeah, that's a good point. You really think much of modeling until you saw calculus. See, K-Bars makes an interesting point about the biostats class where, like, you'll be doing things about biology, but it might be focused on the statistics. So if it does seem like it has, like, a statistical slant, or, like, it's not, like, that much about the biology, like, you might be talking about something involving biology, but the stuff you'd be doing is more universal. Oh, yeah, sure. Because, like, I think the 4 that we talked about from the CSCE department are, like, the big ones, and the 2 you could kind of base off just, like, if the professor is good, to be honest. So for biostatistics, the course in Introduction to Topics in Biological, Medical, Health, Environmental Statistical Concepts, and Reasoning. Topics include Introduction to Biological Data Processing Analysis, Hypothesis Testing, Non-Parametric Tests, Logistic Regression, Poisson Regression, Statistical Methodologies, Analysis of Survival Data, Kaplan-Meier Estimator, Cox's Proportional Hazard Models, Time-Dependent Covariates, Multiple Failure Outcomes, Typical Biomedical Applications, including Trials. That sounds pretty general to me. Like, you should consider that. Does it? So somewhere applied? Maybe things that, like, I recognize were pretty, like hypothesis testing, regression. This stuff at least sounds, Kaplan-Meier estimator sounds general, but maybe not. Oh, as in, okay, you're saying applied in a different context. Neyman Pearson lemma? Maybe Linux physics. I don't think that's on the table, unfortunately, but this is a lot of symbols. Is that the joke? Rejection set R? Yeah, I have no idea what this means. I have no clue, Doomwood. Oh, as in, okay, yeah, as an example of, like, the foundations. D's is hard sell for non-math majors, which is frustrating. Yeah, that's true, Stooky. It's really useful. D's course 1 could create throughout most solving first order equation. Replace that with... Yeah, that's kind of how my math biology classes have been going. Like we've been talking about like difference equations, and then we kind of and then we graduate into differential equations, and we only ever solve them numerically. But the big thing with differential equations in my math bio classes is stability analysis, and that's a really like useful thing too. You know, a decent chunk of D's except for Laplace transform and stuff. Okay. So yeah, we've chosen. I guess there's four like I think things that are really good / important to do from the CSCE classes. So you need to do two others. So I would base these off like honestly off the how good the professor is. It's like biostats, maybe business finance. I'm usually not too interested in stuff like that, but like if the professor is good, that could be good. Discrete math could be helpful, but maybe not depending. I don't know, for data science, sort of. Numerical methods would not be a bad one at all. Graph theory could be helpful too. And then modeling. Yeah, these ones are kind of a toss-up. Like they have like a bit of overlap with data science, but like it's a little bit hard to sell that any one of them are more important than the other, in my mind. Be able to say qualitative things without solving? Yeah. Discrete is useful because you deal with finite data sets. The theorems are done with infinite / continuous things. In practice, it's all discrete. Fair. But yeah, Doomlight, I guess good luck with your studies. Principles of marketing classroom, the local pub. That is a very strange one to have thrown in here. I'm not sure why this is a data science elective. Maybe it's like applied data science or something. Sure, Doomwood. Discrete maths will probably involve some stuff about graph theory and linear algebra, like the one my sibling took. Maybe. Discrete math is a weird one where like a lot of schools have their own definition of discrete math. My discrete math class was kind of a nightmare. I really didn't like the professor, but I think it was like logic, set theory. Ooh, what else? I can't remember the. Yeah, it's like a good dash of combinatorics. Okay, this is the discrete math for Doomwood School. Ooh. A little bit of number theory. Oh yeah, that looks pretty typical, I guess, for what I think of as discrete math. This is, I guess, more than I did in my discrete math class. Isn't this just Olympiad math? Kinda, yeah. Besides, like, integrals. I think of, like, like the number theory section for sure, and combinatorics, too. Discrete math is not linear algebra. Linear algebra with only -1, 0, 1 matrices. Yeah, linear algebra is a little bit of a weird one for discrete math. there's kind of some parallels where you can think about like linear combinations of two numbers, but just like with integers instead of real numbers, with like GCDs. I mean, but it's not that much of a connection. So yeah, I don't know. I personally did not enjoy my discrete math class that I took. And I don't generally enjoy that type of math, but other people do really like that type of math, so it depends on you. I should probably just start putting something down here. Look into that. DM was in my initial elective set. Okay, yeah. I for nothing on the list jumped out to me as being super helpful for data science, but I think at some point you're gonna have to take a class that isn't all that relevant to data science with that list of electives that you were given. I guess overall, though, the more interested you are, the more you'll get out of it. Some useful courses, but you'll be good at what interests you. Can't do complex analysis. The reason I could do complex analysis is that I spent like 3 months before the course studying for it, and then I took a course in it. So I feel like I'm pretty good at it now, but spent like, I guess in total, like 6 months studying it. Some core classes like freshman writing, absolute mockery. Good old gen eds. All right, this is a cool plot. I should probably explain where this comes from, though. Oh, interesting. Doom wood. So in this like example file, there's data about like the ocean temperature each year. And so the point of this data is that there's like a long-term kind of oscillation if you kind of take the average of all these spikes. But there's also all these like short-term like oscillations too. And if you use wavelets on data like this, it's like a Fourier transform but localized, or like it's like a Fourier transform but for different scales, I guess. So it's going to show us the frequency, like kind of like the long-term trends in this data, but also like the short-term like spikes. And so this is kind of like a heat map of what you get if you use wavelets. Dealing with traffic collision data, it's similarly periodic but noisy. Ooh. And so the vertical axis here is period, so 1 over frequency for some reason. So height, like this is the low frequency up here, high frequency is down here. And then the same time axis is the horizontal axis. So if you take like a horizontal slice across the top, you can see there is, for pretty much all of the data here, there is like a low frequency trend because it's not all dark blue. And then I don't know. I don't quite know how all to interpret this. There's kind of a lot going on with this. It does look pretty. It's kind of like, it's almost fractally with these like forks. The music stopped, by the way. But yeah, you can also look at like vertical slices if you want to know what things were like in the year 1900. You can just kind of like take this slice and see what kind of like frequencies existed. What music am I gonna play? That playlist is 3 hours and 20 minutes. I've been streaming. Wow, I've been streaming for a minute. Okay. What was I doing with this? Oh yeah, so I just need to start playing around with different levels of DWT. So I think the different levels that we're talking about are the different frequencies. It's like different horizontal slices of the data. I think this is basically just one horizontal slice here. And apparently when you have noisy data, you can kind of overcome that noise by looking at different scales. And so instead of using DWT2, I want to try using Wave Deck 2, I guess. And actually, print pywt dot, wait, oops, pywt dot dwt max level, wait, well, dwt or dwtn? Input data shape wavelet. Noisy dot shape. Har. 9. Okay, good to know. 9. So if I do level equals 9 here, I should get the same exact image out. Well, that didn't happen, now did it? Is this returning the thing I think it's returning? It might not be. Actually, wait. I can do that down here. Well, comment. Oops. That is hard to read. Okay. I think I might be getting level 0 through 9. And there's a couple different level of indices to deal with here, so I'm trying to work out. Noisy DWT 1. So it's a 2 tuple with n many 3 tuples for the second slot. So now there should be 9 of these 3 tuples. So I want the 8th index. Then within that, well, yeah. Thruples? Yeah. Okay, so I think maybe inside of all these, I insert 8. Now is it the same thing? Tuple index out of range. The hell it is. Okay. How do I how do you get the length of a tuple in Python? Is it length parentheses len? Okay. Confused about what it's actually returning to me. $10. Really? Okay. Is that okay? What is length of the first one? 1? Yeah, there's this like length thing. So wait, okay, it's not a tuple, it's a tenpole. So if I want, maybe I need the 9th level. Aha! Okay. Is that the exact same though? I wish I didn't delete the old one. What was the thing I had here? DWT2? Okay. Oh, restart. Jupyter Notebook is kind of, it's really convenient for certain things and really inconvenient for other things. You are not, oh wait, yes you are out of range. My bad. I think I need to restart it again though. Oh. 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 Okay. Well, these do look the exact same. That's a good sign. Now what? We definitely want a higher threshold. mean, do we? Maybe we don't. So the technique that I think we're going to use to deal with a noisy image is we're going to look through the last, so we're looking just the last level here. But if we look through the last 3 levels, apparently only the edges that are actually there should be consistently showing up throughout those 3 levels, and all the dots that are just a product of noise should cancel out. And we might need to do more than 3 levels, but I think that's the idea. We just look at see which ones are consistent throughout each of these levels. How do I want to actually accomplish that? Oh. Oh. Okay, I think I potentially have an idea. You know, let's be lazy. Well, no. Oh wait. There's another issue to deal with. I need to figure out how to say it. Print noisy DWT 9 0 dot shape. Print noisy DWT 8 0 dot shape. That's the issue. For each level you go down, you lose half of your elements. Like, each level is half the resolution of the last one. And so if I want to compare, if I want to like add 2 different levels together, we need to do the homework suggested upscaling. Or figuring out how to do it yourself. But that sounds like a pain. Ugh. Well, crap, I can't actually make progress on this until I figure out this piece of the problem. Because what I want to do is add, like, I want to literally add different levels of these together. But I can't do that if they're different sizes. It might be a good time for a break anyway. Like, I might just call the stream here then. Yeah. I think it's a good place to to call it, because I need to go figure out what library to use for this upscaling, and I don't really want to do that on stream. It's like, not right now. Yeah. Sit on it and think. So that'll be it. So yeah, anyways, here on YouTube, thanks for being here. I'm gonna cut the YouTube stream off here. On Twitch, we'll look for a raid.